Okay, so we'll pick up with problem 12 here. In problem 12, we want to use the change of base formula to find each value. Okay, so sometimes we want to change the base of a logarithm to make it a new base. I'm using law 8 on this sheet here, so I'm going to change the base A, to make it a new base B. Okay, now usually when we want to do this, we want, like, the intent is to go to the calculator to have a solve. Okay, so most calculators have a log button and an ln button. Okay, so like it makes the most sense to change the base to either base 10 or base e, because then we can use the calculator to do the calculation. Okay, so let's do part A. I got log base 6 of 0.77. I'm going to change that base 6, to make it a new base e. Okay, so I got log base e, which is the same thing as the ln, of 0.77 divided by the ln of the old base. The old base is 6. Okay, so let's go ahead and type in that next. We got the ln of 0.77 divided by the ln of 6. Okay, and let's see, I'm getting negative 0.146, looks like, to the nearest 3 digits. Make sure that you're rounding that. I don't want to say that this is equal, okay, because it's an infinite decimal. We just chose to round it to 3 decimal places there. So that'd be the answer. Okay, so log base 6 of 0.77, that's approximately negative 0.146. Okay, now when I change the base, I can make the new base be any number I want. Okay, again, the idea though is that I'm going to go to the calculator because I don't have a log base 6 button. Where I type in the log base 6 button and then I'm done, right? So I have an ln button and a log button. Okay, so let's go ahead and do part B here next. You got log base 9 of 85 plus log base 7 of 17. Okay. 9 to what power gives you 85? I don't know. Or 7 to what power gives you 17? I don't know. So we can't use our laws of logarithms here in order to simplify that. Like, we're going to have to change the base, okay, to make it a new base. So I'm going to make the new base be base e. It's not going to matter. Okay, now I'll explain why at the end. But let's see, I'm going to have the ln of 85 divided by the ln of the old base is base 9 on that first logarithm, plus the ln of 17 divided by the ln of the old base. The old base is 7. Okay, let's go ahead and type that in there. So we got the ln of 85 divided by the ln of 9. Okay, and then it'd be plus the ln of 17 divided by the ln of 7. And type in the whole thing all at once if I want to here. Okay, and so the answer that I'm getting is about 3.478 if I go nearest 3 digits. That's a rounded off number, so I'd want to use the approximation sign. Okay, and that'd be my answer. Now, it does not matter what the new base is. I can make the new base be anything. I'll get the same answer still. Okay, so like, let me just show you here. If I have the new base be base 10 instead of base e, then I'm going to have log of 85 divided by log of 9 plus log of 17 divided by log of 7. I get the same answer. Okay, so that's the point that I'm making, is that it's not going to matter that, what the new base is. Just the idea, though, with changing the base is because you're going to go to the calculator and have the calculator give you the result to that. Okay. Let's see. Problem 13 is next. So in problem 13, we want to expand log base 5 of 25 times x cubed divided by y to the fourth and give the answer without exponents. That's how the book is going to want this also. Okay, so let's do that. Now, the first thing that I see is that I'm dividing two things in this logarithm. Right? So using log 2, I can split that into two logarithms that would be subtracted. Okay, so I did that. I got log base 5 of 25x cubed minus log base 5 of y to the fourth. Okay, now the next thing, I got 25 times x cubed inside that first logarithm. So let me use log 1, because I'm multiplying two things in that first logarithm there. And I'll go ahead and split that into two logarithms. So I'm going to have log base 5 of 25 plus log base 5 of x cubed. And then we got minus log base 5 of y to the fourth. Okay. 25, that's the same thing as 5 squared. Right? And I know powers can come out in front of logarithms. So that's using law 3. Right? This R value comes out in front. So I'm going to have 2 times log base 5 of 5. Log base 5 of 5 is 1. And 2 times 1 is 2. Plus log base 5 of x cubed minus log base 5 of y to the fourth. The last thing will be to pull these powers in front of these logarithms here. Again, I'm using law 3 to do that. Okay, pull the R value out in front. So my answer is going to be 2 plus 3 times log base 5 of x minus 4 times log base 5 of y. Now that would be as simplified as I can get things. Okay, so I'd circle that answer there. Okay. Problem 14. They want us to write log base 3 of x squared plus 3 plus 4 times log base 3 of x minus 2 minus 1/3 log base 3 of y as a single logarithm. Okay, so let's go ahead and do that. Now this 4 that's in front of the logarithm, the second logarithm, I can pull that back inside as a power of the inner part. Right? I'm using law 3 to do that. So just as powers can come out of logarithms, like if I have a multiplier, like in this case I got 4 as a multiplier, I can pull that back inside so that's a power of the inner part. Okay, so I'm going to have log base 3 of x squared plus 3 plus log base 3 of x minus 2 to the fourth, and then I can do the same thing with this 1/3. It's going to be minus log base 3 of y to the 1/3 power. Y to the 1/3 power, that's the same thing as the cubed root of y. Okay, so then now if I get my single logarithm here, I'm adding these two logarithms. So if I get a single logarithm out of that, I'm going to multiply the inner terms. And then I'm subtracting this logarithm here at the end. So I'm going to divide by the cubed root of y at the end. Okay, so my answer will be log base 3 of x squared plus 3 times x minus 2 to the fourth divided by the cubed root of y. Okay, and go ahead and circle that. That'd be as simplified as we can get things there. Okay. Let's try problem 15 is next. It says the lifespan of a sample of sparrows of a sample of robins was studied. the equation y equals 2 minus log of 100 minus x divided by 0.42 calculates the number of years y for x% of the robins to die off. How long will it take 70% of the robin population to die off? Okay, so x is the number of the percent of the population to die off. So I need to let x be 70 and plug that into this equation here. 100 minus 70 is 30, right? So I got 2 minus log base 10. There's no base written, so it's understood to be base 10 of 30 divided by 0.42. Okay, and then I can go to the calculator and type this in. So I got 2 minus log of 30, and then I'm dividing that by 0.42. Okay, so I get about 1.2, and the units here, the y value, that's in years, right? So it's going to take about 1.2 years for 70% of the robin population to die off. Okay? All right, we'll go ahead and stop the video right there. And now in the next video, we're going to get some practice solving logarithmic and exponential equations. Now, this is very important stuff, okay? We'll start the next video with problem 16 there, okay?